You know, talking about this yesterday, Jacob, I'm surprised, but all these Morse codes you've done, no rainbow action.
Haven't talked about this type of atmospheric optical phenomena. I've done other ones, but rainbows are probably the most common optical phenomena we see in the sky. And now that we're getting some rain showers in the region at times, some great sky spies that have submitted photos inspired me to do this topic about what causes and the ingredients that we need to form rainbows. So there's 4 main ingredients. We need to be between the sun and the rain. The sun needs to be at our back, and we need to be looking towards the rain shower. It must be within a few hours of sunrise or sunset for rainbows to form, because the sun has to be at an angle less than 42 degrees to the horizon. So it has to be fairly low on the horizon so that it can pass through those raindrops and refract and scatter the light so that we can see all of the component colors. The rainbow will appear at the point opposite the sun to us, and the larger the raindrops are, that creates brighter rainbows. So the size of the raindrops matters, and the larger the raindrops are, we can see a more vibrant rainbow. So it's an optical phenomenon. No two people have the same perspective of a rainbow. So it's very unique to your exact viewing perspective, the type of rainbow that you see. So inside of a raindrop, as the sunlight enters it, it first is refracted. So that happens because we're going from air to water. So light slows down and bends when it goes into that more dense medium. The different colors have different wavelengths, and each color is refracted by different amounts. This dispersion then causes the white light to split up into its individual colors because of the different wavelengths of that visible light spectrum. So then red is on the top of our rainbow because it has the longest wavelength and it bends the least. 42 degrees is the angle between the sunlight and our line of sight as it comes out of the raindrop. Violet is on the bottom of the rainbow because it has the shortest wavelength and it bends the most, coming out at a 40-degree angle. So the sunlight comes in, is refracted. When it enters the raindrop, is reflected off the back of it. At least some of it is reflected. Some of it escapes out the back of the raindrop. But then that reflected light gets refracted one more time as it comes back to the observer, which is us. So the sunlight hits raindrops at different angles, but due to their curved surface, the light gets concentrated in what are called caustics. And those we see all the time in nature with curved surfaces. You can see that in a coffee mug. You could see that with rippling water, the concentration of light. But it's the specific concentrations of different colors that deliver us the rainbow, because each color has a different angle that it's concentrated at for us to see rainbow with all those colors next to one another with the different concentrations at different points in the sky. So the center of the rainbow's arch is at the point opposite of the sun. The lower that the sun is to the horizon, the larger or wider that the rainbow arch will be. We usually just see the top of the rainbow because it's a full circle, but the ground blocks the bottom half of it. If you're up in an airplane, you can sometimes see that full ring or circular rainbow that is coming out from those raindrops. So the light inside the rainbow arch is reflected by raindrops too, but reflections overlap and the colors are mixed to form white light again. That's why it's brighter underneath our rainbows. It's only the difference in the maximum scattering angles of the different colors of light creating the concentrations of those different colors, because again, each color has a different wavelength. That allows us to see the different colors of the rainbow coming out of those raindrops at exactly different angles, concentrating those different colors at precise angles in the sky. So each raindrop is projecting a rainbow cone back at us, but we only see one color of the rainbow per raindrop, as the angle has to be perfect between the sun and our eyes. The other colors pass above or beside our eyes that are coming out of each raindrop. So we see the red color first from raindrops higher up in the sky, and then the violet colors, which are on the bottom of the rainbow, from raindrops that are lower in the sky, since their angle of reflection is shallower than the red light. So raindrops in between the red and the violet raindrops that are scattering that light back fill in the other colors of our rainbow. Finally, double rainbows happen when the light gets reflected twice inside of our water droplets, the reflection of the reflection. And this actually happens all the time, but the second rainbow is usually a lot more faint. Sometimes you can get enough concentration of those colors to see it. So the second reflection creates a concentration of colors at a higher angle in the sky, but it's fainter since light is lost with each reflection. And the colors are inverted with that second rainbow. The second reflection inside the water droplet flips our colors around, putting red on the inside of our second rainbow, but again, it's still on the top of our primary or inside rainbow. And then in between the two rainbows is what's called Alexander's dark band. No light is reflected once or twice inside of our raindrops at these particular angles due to the raindrop shape. So that's why we have that darker band in between the double rainbow, and then again the brighter white light is being scattered below the primary rainbow. And with glories, which are some kind of circular rainbows, they're a lot smaller. They require tiny water droplets, usually in mist or fog. There's a lot of other types of special rainbows that you can see and you can find on the internet, but the double rainbows are some of the more common ones, and it's pretty special when you see the double rainbow in the sky after a rain shower.
That's so true.
I'd love to see a rainbow right now, right? Maybe we had a nice rain.
Yes. That would be so nice. However, two things I want you to cover next time, though, is why you can never catch a rainbow and the leprechaun.
Where's the gold at the end of it?
Looking for the gold.
I feel like it's time to move on. We're going to go to...
You'll be running to find the end of the rainbow. You'll never find it.
Somewhere over it, right?
Yeah.